Look up at the night sky. What do you see? Thousands of stars twinkle above us. Each one is a distant sun. These stars are vast balls of burning gas. They are scattered across the universe. They are not just beautiful, they are essential. Stars are the building blocks of galaxies. They create the elements needed for life. Their life cycle is a story of immense power and beauty. From their birth in cosmic clouds to their explosive deaths, stars shape the cosmos. They drive the evolution of galaxies. They seed the universe with the ingredients for planets and life itself. This essay will journey through the extraordinary life cycle of stars. We will explore their formation, evolution, and eventual demise. Join us as we unravel the mysteries of these celestial wonders. Stars are born in vast, cold clouds of gas and dust. These clouds are called nebulas. Nebulas are like cosmic nurseries. They are scattered throughout galaxies. They are mostly made of hydrogen and helium. These are the simplest elements in the universe. The gas and dust in a nebula are spread out, but gravity slowly pulls it together. As the material clumps together, it becomes denser. The cloud's center heats up. This central region is called a protostar. The protostar continues to grow. Gravity pulls in more gas and dust. The temperature and pressure in the core rise dramatically. When the core gets hot enough, something amazing happens. Nuclear fusion begins. Nuclear fusion is the engine of a star, the very heart that powers its brilliance. It is the process of combining atoms, specifically hydrogen atoms. This releases enormous energy, far greater than any chemical reaction. In the core of a young star, hydrogen atoms fuse to form helium, a process that sustains the star's luminosity. This fusion releases a tremendous amount of energy. This energy pushes outward, counteracting the force of gravity. It balances the inward pull of gravity. The star becomes stable, achieving a state of equilibrium. It shines brightly. A star that is fusing hydrogen in its core is in its main sequence, the most stable period of its life. This is the longest stage of a star's life, lasting billions of years. Our sun is currently in its main sequence, a phase it has been in for about 4.6 billion years. It has been shining for billions of years, providing the energy necessary for life on Earth. It will continue to do so for billions more, ensuring a stable environment for our solar system. The color and brightness of a star depend on its mass, with more massive stars appearing bluer and brighter. More massive stars are hotter and brighter, burning their fuel at a much faster rate. They burn through their fuel faster, leading to shorter lifespans. Smaller stars are cooler and dimmer, often appearing red or orange. They live much longer lives, sometimes lasting for trillions of years. Our sun is a yellow dwarf star. It is of average size and brightness. It lies at the heart of our solar system. Everything in our solar system revolves around the sun. Its gravity holds the planets in their orbits. Its light and heat make life on Earth possible. The sun is about halfway through its main sequence. It will continue to fuse hydrogen for another 5 billion years. After that, it will begin to change. The sun will eventually exhaust the hydrogen in its core. When this happens, it will enter a new stage of its life cycle. This stage is no less fascinating than its birth or its long, steady main sequence. When a star like our sun runs out of hydrogen fuel in its core, its life takes a dramatic turn. The outward pressure from nuclear fusion lessens. Gravity, now the stronger force, starts to compress the core. This compression causes the core to heat up even more. The intense heat from the core then starts to burn the remaining hydrogen in a shell around the core. This shell burning generates even more energy than before. The energy pushes outward, causing the star's outer layers to expand dramatically. The star swells up to many times its original size, becoming a red giant. As a red giant, the star's surface cools down, giving it a reddish appearance. Despite being cooler, it becomes much brighter due to its larger surface area. Our sun, when it reaches this stage, will expand to engulf the orbits of Mercury and Venus. Earth, even if it escapes being swallowed, will be scorched by the sun's intense heat. Stars much more massive than our Sun evolve into supergiants. These supergiants are even larger and brighter than red giants. They burn through their fuel at an astonishing rate, living much shorter lives than their smaller counterparts. Both red giants and supergiants mark a crucial turning point in a star's life. They represent the beginning of the end, but also a phase of incredible transformation and cosmic significance. While smaller stars like our Sun eventually fade away, massive stars end their lives in a spectacular explosion called a supernova. These supernovae are some of the most energetic events in the universe. They briefly outshine entire galaxies. These cataclysmic events occur when a massive star runs out of fuel in its core. Without the outward pressure from fusion, the core collapses in on itself under its own gravity. This collapse happens in a fraction of a second. It creates a shock wave that rips the star apart. The explosion scatters the star's outer layers into space. These layers contain a rich mix of elements. Supernovae are essential to the universe. They are the primary source of heavy elements. These elements are the building blocks of planets and life. After a supernova, the core of the massive star remains, a remnant of the once colossal celestial body. This core is incredibly dense, packing more mass into a smaller volume than we can easily imagine. The fate of this stellar remnant depends on its mass, determining its ultimate transformation. If the core is less than about 3 times the mass of our Sun, it becomes a neutron star, a fascinating object in the cosmos. Neutron stars are incredibly small and dense, with a teaspoon of their material weighing billions of tons. They are made almost entirely of neutrons, particles that are usually found in the nuclei of atoms. These stars spin rapidly and emit beams of radiation, creating a lighthouse effect in space. If we are in the path of these beams, we see them as pulsars, blinking on and off with precise regularity. If the core's mass is greater than 3 times the mass of the Sun, gravity takes over completely, overpowering all other forces. The core collapses into an infinitely small point called a singularity, where the laws of physics as we know them break down. This singularity is surrounded by an event horizon, a boundary beyond which nothing can return. Nothing, not even light, can escape from within the event horizon, making it a region of complete darkness. This is a black hole, one of the most mysterious and powerful objects in the universe. Smaller stars, like our Sun, don't explode as supernovae, but they have their own dramatic end. Instead, they shed their outer layers in a gentle process over time. These layers form a glowing shell of gas called a planetary nebula, a beautiful and colorful sight in the night sky. The remaining core is a white dwarf, a dense and hot remnant of the star. White dwarfs are small and dense, with a mass comparable to the Sun but a volume similar to Earth. They slowly cool and fade over billions of years, eventually becoming cold, dark remnants of their former selves. Stars are essential to the universe. They are the building blocks of everything we see. They are more than just points of light in the night sky. They are cosmic engines powering the universe. They drive the evolution of galaxies, shaping their structure and dynamics. Stars create the elements necessary for life, from hydrogen to the heavier elements. Stars produce heavy elements through nuclear fusion in their cores, a process that powers them. These elements are scattered throughout space by stellar winds and supernova explosions, enriching the cosmos. This cosmic alchemy enriches the universe, providing the ingredients for new celestial bodies. It provides the raw materials for new stars, planets, and even life itself. The carbon in our bodies, the oxygen we breathe, and the iron in our blood. All were forged in the hearts of stars, billions of years ago. We are literally made of stardust, connected to the cosmos in the most fundamental way. Stars are also essential for planet formation, creating the environments where planets can form. When a star forms, it is surrounded by a disk of gas and dust, known as a protoplanetary disk. This disk is called a protoplanetary disk, a nursery for planets. Planets form from the material in this disk, gradually coalescing over time. Gravity pulls the dust and gas together, forming planets and other celestial bodies. Stars and their planets form together in vast cosmic clouds, creating the diverse universe we observe today. The life cycle of stars is a continuous process of birth, life, and death. Stars are born in nebulas. They live for millions or billions of years. They die, sometimes in spectacular explosions. The material they eject is recycled. It forms new stars and planets. This cycle ensures that the universe is constantly evolving. It is a beautiful and awe-inspiring process. Next time you look up at the night sky, remember the amazing life cycle of stars. They are not just distant points of light. They are the building blocks of our universe. They are the creators of the elements that make up everything we know. They are the engines of cosmic evolution. They remind us of the vastness and wonder of the cosmos.